that is some absolutely pure ethanol from cheap Hawkeye vodka coming off of my Luddite Redneck Vodka whiskey still. Damn, that's going to make some good infused vodka in the future. Definitely going to have a party. Okay, so welcome to today's show of Southern Iowa Luddite. In this episode, I'm going to build a Mad Max whiskey gin vodka still. The goal of this project is to do it with things that's readily accessible to everyone, either at a hardware store, side of the road stuff, things like that. And then the other one is to take really rock gut, cheap vodka. Here in the state of Iowa, we have Hawkeye and Cyclone vodka. It's like $14 a handle. We're going to redistill that with this still and infuse it and make some really good vodka from that. Let's get to this. So first thing is, I found at the side of the road this All-American cast aluminum canner, probably circa 1950. This is going to be great. These things are keyed in, and it's going to seal up just real nice. We're going to have to take this fitting with this rubber O-ring, drill a hole, and then that's where the distilling head is going to come out. We're going to take all these parts from a local hardware store. We'll make a reflux column here, and we'll get theoretical plates by throwing stainless steel Scotch-Brite pads in there. We'll have a thermometer here, so this is just a basic thermometer. And then we'll build a condenser by having a 1/2-inch pipe run through a 3/4 inch. We'll have water coming in, we'll have water coming out, and then we'll have a little 45-degree leg here. That'll be the drip tube. Just real simple stuff. We're going to take some propane, just standard plumbing and sweating, and yeah, we're going to hack this thing together, and by the end of the episode, we'll be distilling some vodka out of it. Okay, so let's get to work on this pot here, and what we have to do is we've got to take this handle off. I'm going to use the pressure regulator on here. Not going to mess with that until we know if it leaks. Same thing with this pressure relief valve over here. That's kind of a nice safety feature. But anyway, I need to get this off so I can drill a hole in there, and so we can get this fitting on that will allow me to connect with a good seal from the pot through here to the copper fitting. Okay, so that's done. Let's see if we did any good. This is kind of what I was hoping for. This is 3/4, I call it a burr out bit. I'm sure it's got a more technical name. And same thing here. So I think it's a nice tight fit. I can't slide it through. I'm hopeful that the cast aluminum will not mess up these stainless steel threads, and I can carefully put a wrench on this and maybe thread it in and then thread it back out, and it should seal real nice. So let's see how this goes. Okay, let's see if we got a slightly larger drill bit. Living up to the mantra of this channel, get it done with what you got. I got 11/16 bit here. Clearly not big enough, but with the longer shaft, hopefully I can kind of waller this out a little bit more. so I can thread that fitting on. Let's see. I don't want to get too excited here, but that thing may be starting to bite in and thread itself. Okay, there it is. That went fairly well. Hopefully I didn't jack up this copper fitting here. Okay, so I'm not going to show a whole lot of assembly video here. There's plenty of great videos out there that you can teach yourself how to sweat copper pipe. But basically what you want to do is you want to shine up the surfaces that are going to come in contact with the heat and the solder. And basically the elements of this are compound called flux. Put some of that on there. Throw some in here. So we got the flux in there. Now what you want to do is you want to heat the metal and let the heat suck the solder in. Do not melt the solder. Let the heat of the metal melt the solder and let it suck in. Not quite hot enough yet. And again, I'm not a professional plumber, but I have sweat quite a bit of pipe. Almost there. If I had some MAP gas, it'd be better. I've just got propane here. And there you go. That's all you got to do. Okay, so before I start sweating a bunch of pipe, I wanted to show you the most important thing here, which is our reflux column. What we want to do is we want to shove either, ideally if we had copper, this would be even better, but stainless steel will work. And how this works is we want to take this stainless steel, stretch it out a little bit, and shove it in this tube. And so what this does is this creates all kinds of plates in chemistry, science, engineering, theoretical plates, which then gives resonance time to the ethanol molecules from everything else. And so then that's how you can distill out ethanol from trace methanol or water or whatever else is in the mixture. So all you do is shove it in here. The more you get, the better. And then we'll have a reflux column. The reason why I'm using this stainless steel is it's a whole lot cheaper than buying the copper equivalent. Okay, so I think you get the point. I'll finish this off and then I'll put it on time lapse and start sweating all the pipe here. Okay, real quick, I wanted to show you here kind of a important section of this build. So we've got the Reflux Column all plumbed up, Ray. Got this kind of complicated looking little interface here. As you can see off this 45, this is where the condensing column will be attached once it's built. But what's really important here is this is where we're going to put the thermometer, and so we'll have the vapor temperature right here. We'll know that we've got pure ethanol coming off of the pretty low-end Hawkeye vodka. Okay, here's the initial setup for the condensing column. So what's going to happen is water will flow in, it'll flow this direction, and then flow out once we seal both ends. So as you can see here, we have 3/4 inch copper, and we're going to fit 1/2 inch in here, which is ultimately what will connect up in this area. But before we do that, we have to be able to slide the 1/2 inch copper tubing that's going to carry the vapor of the ethanol or whatever we're distilling, and it has to be able to slide through there. But if you look in there, there's that little protrusion right there. I guess there's only one, and that's a stop that doesn't let you slam 1/2 inch into 3/4 if you were plumbing this for something other than a condensing column. So anyway, I've got to take a Dremel tool, get rid of that, and then sweat this all together. So see you when I'm done with that task. Okay, let's get a first look at this bad boy. So again, the All-American cast aluminum pot, canning pot, circa 1950. It's a pressure cooker, to be specific. We've got our reflux column where we've got theoretical plates. We've got a nice thermometer in here. Boiling point of ethanol is 79 degrees Celsius, or about 173 degrees Fahrenheit. So the vapor of the gaseous state of the ethanol, the vapor will come up here. We'll measure the temperature right there. It'll come down through this area. It will go into the condenser where we've got water. Cold water will flow in around the 1/2 inch tube inside of there, exit out this port, and then the pure ethanol will drip out of the bottom of that tube. So yeah, this looks good. Really pleased with it. Think it's going to work well. Think all that's really left to do here is just shine it up and test this bad boy out with some cruddy Hawkeye vodka and see if we can isolate some fairly pure ethanol off of it. Okay, as I say, this is the moment of truth. So we're going to charge this very affordable Hawkeye vodka, 1.75 liters, 80 proof, that's 40% weight by alcohol. And we're going to start using my hillbilly distilling rig here, and let's see how this goes. So first step is to carefully pour in the very precious vodka here. Okay, so we're keyed in properly. Okay, so it's time to turn on the hot plates. Get my first collecting mason jar set up. And now for the distilling cooling water. The condenser is good and cold, and all we have to do is wait for the proper boiling point at the top of the distillation head where the thermometer is, and we'll start collecting fractions. Okay, so a little bit about this build of the still. So first goal of this was I wanted to really do something that anybody could do, right? This is a Mad Max effort. So we've got just a by the side of the road ancient pressure cooker, cast aluminum, fairly easy to fit that stainless steel coupler in there just with a simple drill bit. What I really like about using this pressure pot though is I can see while I'm distilling here whether or not I'm generating any pressure in case I've got some blockage, and I do have a pressure release valve here. So that's really nice. I like that a lot. So I can really pour the heat off of these heating plates, just kind of max, get it up there real quick. And then, as I said, I really like where I got this thermometer, simple brewer's thermometer. It goes into pots and kettles and stuff, really easy to interface, just standard copper. We've got that stainless steel scrubber using for theoretical plates, which is really nice, really convenient. And then we've got good water flow in and out of the condenser. And then hopefully eventually we'll collect some good stuff here. So yeah, really excited how this turned out. I think this is something that'd be extraordinarily achievable for anybody that wanted to do this. And you know, if you got questions, comments, concerns, just slam them in the comments here. I know I'm going to get some haters for using aluminum here, but trust me, this aluminum isn't going to cause any problem with the ethanol that I'm going to distill here. So this is a good example why not all vodka is the same. So we're a little over 80 degrees here. But if you look down in here, we're clearly getting some light fractions coming across. That's not ethanol. That's not so great to drink. We'll keep collecting that until we get up to the ethanol temperature. Man, this is why you want to pay up for the booze that you drink. So the head temperature is at a little over 100 degrees Fahrenheit, a little over 40 degrees Celsius. We haven't reached methanol temperature. Still getting some lightweight boiling crap off of this. And it's a little dark, and I expected that because I didn't do a distilling cleanse of the still. Doesn't really matter to me. This is a proof of concept run. Okay, so we're at 65 degrees Celsius, so we're going to change out the first jar. Collected everything there. Now we'll collect everything from 65 degrees to the boiling point of ethanol. Okay, so this is starting to hold real steady at 70 degrees, so I may have my thermometer not quite in the perfect position here to measure the absolute boiling point of the vapor coming across. I may rethink the design here going forward a little bit, but I think what I'm going to do is I'm going to switch out and change into jar 3 and see how long this stays at 70 degrees. This is real nice clear material coming across, and looks pretty good. Doubt that there's that much methanol, so this contains all 65 to 70 degree fractions according to the thermometer. Okay, so time to switch again. Jar 3, all fractions collected between 70 and 75 on the thermometer at the head. So now we'll collect at 75 degrees Celsius and see if it changes for a while. Interesting observation there, about 167 degrees Fahrenheit where the pot meets the reflux column. If we look at our vapor head temperature up here, we're at about 170 degrees Fahrenheit or a little over 75 degrees Celsius. And we got a really nice drop rate. So I think we're getting some really pure ethanol right now. And we're going to let it roll in this zone for as long as she wants to roll. So yeah, man, I think this is going to be some good drinking stuff coming out of this jar. Come and get some. That is some absolutely pure ethanol from cheap Hawkeye vodka coming off of my Luddite Redneck Vodka whiskey still. Damn, that's going to make some good infused vodka in the future. Definitely going to have a party. Okay, still holding at 75 degrees C. Time to switch over this incredibly pure cut of flask number 4 to flask number 5. Okay, so we're still steady in that 75 to 76 degrees Celsius range, about 170-ish Fahrenheit. Still getting a pretty nice drip rate. I'm on jar 5. I'm at about 450 to 500 milliliters of what I would say is really good absolute ethanol. It's going to be about 95 weight percent ethanol at this point, 5% water. There's an azeotrope that you can't break without special equipment. But what I really wanted to show you here is you got to pay up for your booze. So you can see jar 1 got a lot of light stuff between 28 degrees C and 65 degrees C. That's just junk. And then from 65 to 70, not saying that's methanol, but that's in the methanol range. And then 70 to 75, now that I know how to use this still, I would start cutting at 75. I wouldn't start collecting at 70 degrees C. A great jar of absolute ethanol right there, and then a great jar of pure ethanol there. And oh, by the way, bottoms up. Man, that's smooth. Okay, so that'll wrap up this week's video. We made some incredibly pure ethanol from this hillbilly Luddite redneck still. Common everyday items. If you can sweat pipe, you can do this. If you take nothing else away from this video, pay up for your booze or learn how to do this. As always, get it done with what you got. See ya.